Chromatography. What is it? Well, literally speaking, it means color writing, and it's a method long used in labs for separating mixtures into their component items. In the same vein, ion chromatography, or IC, is the separation of mixtures of ions. This separation takes place on polymers within columns. The column is the heart of any ion chromatography system, and the choice of column can have a major impact on the results. IC has historically been run with conductivity detection. This ultra-sensitive detector measures changes in the conductivity of the fluid passing through it. However, newer IC systems are able to incorporate alternative methods, such as amperometric detection. Now, the mixtures we want to separate on the system are not always very clean and have the potential to damage the separator column. We don't want that to happen. So, to keep the separator in peak condition, we usually put a guard column in front. For the best results, this guard should contain similar material to the separator column. Next, the injection valve. This is how we get a mixture onto the column in the first place. The sample is introduced, completely filling the loop. Then any excess is diverted to waste, and when the injection valve changes position, the sample is pushed onto the column. The actual separation of the mixture, though, requires that the components be able to exist in two phases, a stationary phase and a mobile phase. For ion chromatography, the mobile phase is an ionic solution, and it must travel through the system at a precisely controlled rate and constant pressure. A high-accuracy pump is required to do this. However, since the mobile phase is also conductive, it's also difficult to see the response of low levels of components in the sample. So we use a suppressor to remove high-conductivity ions from the mobile phase and replace them with low-conductivity ones. As a result, background noise is greatly reduced and analyte response is increased. Since the whole system is dependent upon the mobile phase, it is essential that it is created accurately and reproducibly. Utilizing an eluent generator allows us to add only water. An accurate, reproducible eluent is created automatically through electrolysis. Plus, adding in a continually regenerated trap column greatly increases the purity of the eluent, and it's labor-free. Of course, analysis works best when the environment is stable. Thermal control of the separation and detection pieces helps ensure the best results and helps increase the lifetime of the components. The use of radiofrequency identification to achieve an understanding of a column's history removes any need for additional labor and guarantees traceability of results back to the consumable items used. Finally, local control of the instrument ensures that setting up the system is simple. You don't even need to speak English. Video display capability allows in-place troubleshooting assistance to ensure a top-performing system. The Dionex Integrion HPIC system, designed around world-leading chemistry, designed for you.